Okay, so then after that, I just gonna say, okay, here move to EAX EDI plus 34. EDI, guys, is pointing to the PE header of the current process, of the current malware that we are just running. How do I know that? If you click on EDI and go up to see where it was initiated, we can see here that it was initiated with ESI, but ESI is here, which was moved to EBX, and the content of EBX is validating to be the MC header. You remember, MC is the MC header of the binary. So we know that SE holds the initial content of the binary, which is moved to EBX, and here is comparing with the first 2 bytes. After that, you can see that now it is moved ESI again to EDI, but now EDI plus 3C. EBX, as you remember, it is exactly also ESI, but at the beginning of the binary, and EBX plus 3C is the PE header. If you check the Windows binary format, you will realize that that's moved to EDI, and that PE header is compared with PE 5045. In other words, here we can see that it is validating the MC header and then the PE header, and that whole analysis is based on ESI, which is moved to EDI. So EDI is right now at this specific point pointing to the PE header of this binary, of the malware. That's the reason we know that here, down the road, here is the PE header plus 34. And again, if you don't know what is this, you can go to any PE specification, and EDI, which in other words is PE plus 34, is the base address of the malware. That's the whole thing that we just saw here. This is the base address, guys, of the malware. I just pressed colon to enter a comment. Okay, and that base address is going to be compared with the buffer, but this buffer, if you remember, it is the base address of the remote process. Base address of remote process, in this case Internet Explorer. And then what it is doing is comparing basically if the base address of the malware is the same as the base address of the remote process. So let's see that in the debugger. We click on move EAX instruction, and you can see that it's saying 40.0000. That's the base address of the malware, as I just described. And then it's going to compare EAX with the base address of the remote process Internet Explorer, which, as you remember, is 01010000. It knows that it's not the same base address. Okay, since it is not the same base address, the jump is going to be taken. In other words, it's going to come right into this branch. But if the address would have been the same, then it should have gone to empty on map view of section. In other words, if the address of Internet Explorer, the base address, would have been 40.0000, then it would have go there, remove the entire section with empty on map view of section, and then allocate via virtual alloc X in the same space a new buffer. In this case, since it is different, what the malware is going to do is going to come to this branch and it's going to say, okay, since it is different, I'm just going to go ahead and allocate into 40.0000 the address of my buffer where I'm going to inject malicious code. Okay, so let's take the jump. And here we just press F8 quickly. We go to the virtual alloc. We can see the parameters here in the stack. The first one is the process ID, as you remember, is Internet Explorer. The second one is the base address. As you see, since this address was not found being the base address of Internet Explorer, it says go and allocate that space into that process. If you remember in the previous class about create remote thread, this parameter was 0, which means virtual unlock was going to decide the buffer to allocate it in the remote process. But in this case, it is set as 40,000, and therefore it's gonna be allocated. And let me show you something before doing that. If we go here, guys, you can see that there is no 40,000 into Internet Explorer, right? After that call, we will see here that buffer being allocated. Okay, so let's see. We click F8, check in EAX, and it says I allocated in the 40,000 a buffer in the remote process. If we come here, let me just close this again, and we click on properties, then in memory, you can see, guys, that now the 40,000 was just allocated. Okay, if we click in read write process, you can see that it is empty, but it is ready to wait for malicious code to be injected. That's awesome, right, guys? It's really cool. Okay, so now that we have the allocation, after the allocation, it's gonna come here, guys. It's gonna just compare if the base address allocated is 0. If that's the case, get out of the loop, which is not the case because it was properly allocated. Here is gonna do these calls, which are gonna just decrypt a binary in memory. We don't wanna concentrate on that. After that, it's gonna call write process memory. Okay, so let's go right away into the write process memory. So we click on F8 all the way down, and we get right here into the write process memory. It's gonna say inject into Internet Explorer, which is the handler, in the address 40,000, which is the one just allocated. It's gonna write this buffer. If we right click and click on process following dump, we can see that it is a whole binary to be injected. And actually, just a heads up for you guys, if we just go down and down and down, this guy might actually be exactly the same binary, but I mean not the same binary, but little bit modified. But it is also a Delphi binary. You can see here that this program must be run under Windows 32. That's a sign of a Delphi binary that is gonna be injected into Internet Explorer, and the size to write is 3000 hexadecimal. Is the whole binary is gonna be written there. So if we click on F8, we can see that the EAX returns 1, which means it was successfully injected. So if we go back to our process again, right click, properties, go to the memory, and we click on read write, you can see that now it has the whole binary injected. Okay, after that there is one step more to be done by the binary, another write process memory. And this is very important, guys. So since the malware is injecting a new binary into Internet Explorer, in other words, is replacing, well, it's not replacing, it's actually injecting into a new memory space into Internet Explorer, it needs to align the execution code with its own base address. If you remember, the base address of Internet Explorer was not 40,000. You remember it was 0101,000. Okay, what is gonna do the malware right here is gonna go to PEB. You can see here, if you remember, if you write it down, PEB is the address where it's gonna write this specific buffer. If we right click on that buffer, we can see that it is 40,0,0,0. In other words, it's gonna go to the PEB plus 8, which is this address where the base address of that process is located, and it's gonna override it with the new base address of the process, which is starting at 40,0,0,0. That way, when the malware starts executing, it's gonna find the proper addresses in memory. Okay, so we click on F8. It says 1, which means good to go. Then it goes to this very important step, guys. So everything is ready to start executing. Internet Explorer is infected, and now the almost last step is SetThreadContext. Basically, the most important thing here in SetThreadContext is what is the address to be executed first into the remote process as soon as resume thread is executed. Resume thread is gonna release the process from suspended mode into running mode, and it's gonna jump into the entry point of that specific process. SetThreadContext is gonna put it. So how do we know what is the address to be executed? It's pretty easy, guys. You just grab the context address, which is this, and if you print the 01DE0000, which is the context, plus 0xb0, that specific offset holds EAX value, and EAX value holds the entry point of the process to be executed. If we click enter, we can see that that value is 49F92C. Let's write it down. The entry point of IE Explorer is gonna be 49F92C. In other words, as soon as Internet Explorer it resume execution, it's gonna start executing that specific address. Okay, guys. So why we need this specific address? Okay, so the reason is this. I just click on F8, and right before resuming thread, guys, if you remember, what we are trying to do is we are trying to intercept as soon as the malware start executing malicious code into the injected process. In the previous class, we saw that via create remote thread, we can just go open immunity debugger, another session, attach to that specific process, put a breakpoint, and wait for the malware to jump into it. In this case, guys, the process is suspended, as you remember, right? That means that if we go and open immunity debugger, second session, click on attach, trying to find the process injected, you can see that it's not there because it is suspended. So we cannot attach to it. So how we can be able to intercept the injection and before start executing malicious code into Internet Explorer, be able to debug it? There is a technique. I mean, there are multiple techniques, guys, but one pretty cool technique is what it is called the infinite loop. So what we're gonna do is we're gonna go to Internet Explorer into the specific address of entry point that we just grabbed. We're gonna put an infinite loop there so that as soon as Internet Explorer start executing, it's gonna just stay in the same place. Then, since it is running in memory, we attach it with immunity debugger, go to that infinite loop, and patch it back to with the original bytes and resume execution. Okay, guys, so hope you understand it. So as I said, the first step is to put an infinite loop. And let me explain you what I mean by infinite loop. Let me just go down here into Immunity Debugger, and I'm just gonna put here an instruction. In order to put an instruction, I just click on following in dump selection, and here I'm gonna put my infinite loop. The infinite loop is a jump, which is EB opcode. It is a jump, and FE means jump -1. In other words, jump to the previous byte, which is jump to itself. If we click OK, you can see right here that it just set a jump into, it is, first of all, it is in the instruction 40DA4A, right? And then in that instruction is gonna say jump to 44DA4A. It is exactly the same offset. It is just jumping and jumping into the same location. This is what I mean by infinite loop. So what we're gonna do now in Internet Explorer is we're gonna, and just before resuming thread, we know that the entry point is 49F92C. So thanks to Process Explorer, sorry, to Process Hacker, we can just go to this guy, properties, then go to memory, go to the 40,000 that was allocated with the malicious binary. With the binary, we just go to the RBA, which is F9, sorry, 9F, not 90, sorry, 9F92C. Okay, so we go 9F, around here, a little bit down. Okay, 9F 92 right here, 9F 92C, which is right here. We just save that specific value, which is, because we're gonna replace it with the infinity loop, which is 55.8b. Okay, and then here, guys, which is gonna be exactly the address to be executed as soon as the process is resumed, we're gonna put EBFE. After that, make sure to click on write, even right click it multiple times, and then just close it, and we just patch it Internet Explorer in memory. Okay, so now let's allow resume thread to execute. If we click F8, if we go to Process Explorer, we can see that now it's not in suspended mode. And here, check the CPU, guys. Internet Explorer is consuming a lot of CPU, and the reason is because it is just looping. This is like a good sign that our code works properly. Okay, so then now that since it is running, we can go to Immunity Debugger and try to attach it, since we know that that specific process it is running. So we go click on attach, and we can see that now Internet Explorer is running. We click on attach. It says that bad or unknown because it was infected. It's a good clue also. And here, guys, we just break into it. Now, since the debugger break into a specific place, we just click on Ctrl G, and we go to 49F92C, which is the entry point, and you can see that here is our EBFE loop, infinity loop. We just right click, let's just re-establish the original bytes section, and here we are gonna put we just click on keep size so that we uncheck this mark so that it can allow us to write multiple bytes. So in this case, it's going to be 55 8B, if you remember, 55 AB. We click OK, and the final step is right click here and say to the debugger new origin here. Now we do this because we know that exactly we were able to make it run but without doing anything, and that is very important, guys, because normally when the injection process starts executing, it will need some specific values in the registers, and this way we don't alter too much. Okay, now we are in Internet Explorer and we can start stepping into here so that we can see what it is doing. By the way, you can see that based on the specific strings, this looks like actually is kind of similar to the first binary that we were just analyzing, but that's not the point. From here, guys, let me put quickly and again the new origin here. It is very recommended that you dump it from memory so that you can confirm this is either the same binary or a different one, and start following in IDA and in the debugger as usual to understand what it is doing. You can, as you remember, click on only dump X, which is a plugin for Immunity Debugger, dump process. Okay, so you can see that the image base in this case is that one, 400000. The entry point, it is this guy, 49 F22C, which is the relative entry point, and basically you just click on these different options, auto adjust image base address, and just click on dump, and you know, guys, just save it wherever you wanna save this specific file, and you are good to start opening IDA and this new process injected and see what it is doing here. Okay, guys, so we just learned how we can even find code injection in a suspended mode process, and how we can step into it, intercept the injection, and be ready to keep analyzing the malware in memory. Hope you enjoy it.